All right, it's recording. Okay, so with that in mind, we have basically three core lessons in this section: integration by use substitution, integration by parts, and trapezoid rule. These are the three core sections of the things. I'm going over about one or two per section, but that doesn't cover everything. So I'm also made you a playlist of each lesson has its own video for it. Okay, that's from something else, but I didn't make it. But those are pretty good. I checked them out. All right. So let's first talk about use substitution, or I should say this video will just be like a general overview. So first thing, use substitution. In this situation, you have to figure out what do you want to have as your u. So in this case, I want to have a u that when I derive it or make du, it works out to my favor. In this case, I'm probably going to do the u of the thing that's under most restriction. In this case, this is underneath a power of 5. So I'm going to do negative 2 x to the 4th power plus 5. That's going to be my u. My du will be just the derivative of exactly my u. Okay? It's just the derivative of my u. In this case, the derivative of this is negative 8x to the 3rd power dx. So if I were to replace this, negative 16x to the 3rd over u dx. The problem is this is a u and this is a dx. I need them to match. So I need to make this turn into a du. In order for that to happen, I need to have this equal to what I have. So in this situation, I have a problem where this is negative 8x to the 3rd. I want it to be negative 16x to the 3rd. So what could I do to both sides? Multiply it by 2. Good. So I'm going to multiply this side by 2 and multiply this side by 2. So now I'm with 2 du equals negative 16 x to the 3rd dx. Since this matches what I have here, I could replace it with what I have here. So this is going to equal 2 du over u. I could take the 2 out. So 2 times the integral of du over u. And we want to do the antiderivative of du over u, or another way you could think of it as 1 over u du. What's the antiderivative of 1 over u, or 1 over x in general? ln x. ln u in this case. So it's going to be 2 ln u, okay? I know what u actually is. So u is actually negative 2x 4 plus 5. So I'm going to replace that with 2 ln negative 2x to the 4 plus 5. I cannot multiply the 2 back in. You could technically, I would not expect you to do this, but based off log rules, you could do it like this and raise it to the 2nd power because you can move the log to the top. Will I expect you to do that? No. Am I forgetting anything though? Plus C.
He knew it was plus C.
I don't think did you know it when you asked the question?
Why would I ask? Did I forget anything? If I didn't know, I forgot something. It was Dora the Explorer. Dora knows where it is.
Am I missing C?
She's visually impaired.
To be fair, it's always behind her. She's looking at you, the viewer. So
She has Boots. She was like, Boots is her service animal.
that's actually pretty funny.
No, it's serious.
All right, let's do this one. A much.
Diego.
All right, let's talk about Dora lore later. Okay. Next one. The integral. This looks like a tough one, but it's not that bad. Integral of 10 sine negative 2x times e cosine negative 2x dx. Now in this case, the hard part is, which one is my u? Is it going to be negative 2x? Is it the whole sine negative 2x? Is it e? Is it this part? Well, in these situations, you want to look and try to think about it. I'm trying to figure out something that when I derive it, it's still existing. For example, when I derived this thing, it was left with a negative 8x cubed. I had an x cubed. So I knew my derivative worked. So in this case, I'm going to choose cosine negative 2x.
What was it?
We'll worry about that. But my u is going to be cosine negative 2x, which my du is going to be, what's the derivative of cosine?
Negative sine.
Negative sine, negative 2x. But we have something inside the sine, so we have to derive it by the derivative of the inside. That's the chain rule from a long time ago. So what's the derivative of negative 2x? Negative 2. So I'm going to rewrite this as du equals positive 2 sine negative 2x. So in this case, I have now 10 sine negative 2x times e to the u power dx. Remember? Not yet. I need to change the dx into a du, so I have this leftover stuff. So I need this stuff to match with that stuff. So I would make 2 into 10, I will times by 5 in this case. So then this is going to be equals sine negative 10 sine negative 2x. That matches with this. So now I can replace this with u, or du. So 5 e to the u du, which I could rewrite as 5 on the outside, e to the u du, which now I could use the antiderivative of e to the u. What's the antiderivative of e to the u? E to the u, very nice. Now I'm going to plug in what my u is, which was cosine negative 2x. So 5 e to the cosine negative 2x.
Plus C.
Good, plus c.
That's how you
Yes. So you could do it like this, where it's indefinite. You could also do it where you might have numbers in here. Let's say it was like, I don't know, 0 and, to make it easy, pi over 2. So if you had that situation where you had actual definite integral or something with numbers, just make sure you either plug it back in here, 0 and pi over 2, or if you remember, we could convert them early. So what I could do is, let's do blue over here, is if I know when I'm changing it to du at this point, let's say then I want to change these values, which are for x, into for u. So in this case, u will equal cosine negative 2 times 0, which is cosine 0. What's cosine 0? 1. So this would be a 1. U equals 1. And this one will be a u equals cosine negative 2 times pi over 2, which is going to be negative pi. What's cosine of negative pi?
no
Negative half.
0.
It's going to be to the left, so that is negative 1.
Was it negative?
No, negative 1. Just negative 1. Because pi and negative pi is either you went this way or the other way around.
Should you put it in and subtract?
Yeah, so you got to plug it in, subtract. In this case, though, I guess this never realistically, this doesn't often happen. But the negative is on top. It doesn't matter if the negative is top. You still plug that in first. So it's going to be, in this example, I would stop here, right? Because I wouldn't need to plug it back in. But in this example, it'll be 5 e to the negative 1 power minus 5 e to the 1 power. Okay? Which you could rewrite as 5 over e minus 5e.
Plus C.
In this case, no plus c because we're talking about actual numbers. Okay.
Would you give us the numbers or
I have to give you the numbers. I didn't put in a worksheet. I'll print out an extra one for you guys. But this one only has like no numbers. So it teaches the harder skills. So I'm happy with the worksheet. But all right, integration by parts. So integration by parts. Yes. So the official equation for the integration by parts is the integral of u dv equals uv minus the integral of v du. That's the official equation. We could also use the shortcut. So, for example, I'm going to decide that my u in this case, or the thing I'm deriving, is going to be x squared. The reason I chose x squared is because x squared will eventually go back down to 0. So that means what's left over is going to be my integral, which is e to the negative 2x.
No.
Well, it's 1 over e to the 2x, because that's on the bottom, which I'm going to rewrite as e to the negative 2x.
Wait, how come here you put the 1 over e to the 2x, but we didn't do that last time? We didn't keep the fraction, did we?
I think we did, because it was u was on the bottom the whole time, which I made it 1 over u, which caused it to be ln. So I did try to keep consistent like that. Okay, so on the derivative side, we derive all the way down 2x to 0. And on the right side, we're going to antiderive on the other side. Now, the antiderivative negative e to the 2x, usually we would just bring it down. But in this case, what we're going to do is the antiderivative, which I think I saved actually here to show you. Let me see, is it here? Here's just a general thing here, but the antiderivative of something that's over here, you will have to divide by the derivative. Usually you would just bring it to the front. In this case, we're doing it kind of reverse. So it's going to be e to the negative 2x. What's the derivative of negative 2x? Negative 2. So we're going to divide it by negative 2. We're going to do it again. Now we're at this point, though. So e to the negative 2x divided by 4. 2x, my bad. And then one more time. E to the negative 2x. Negative 8.
Why is it negative 2, positive 4, negative 8?
You are dividing by its derivative in this case. So dividing by its derivative versus normal derivatives, we would just multiply by its derivative. Okay, so with that in mind, we could just put this all together. X squared e to the negative 2x, all divided by negative 2. I could do plus 2x e to the negative 2x over 4.
Can you show them now how you got from e negative 2x?
I'll show you one example, and then it'll be the same example every time. Okay, and then let me just write the final answer here. E to the negative 2x over negative 8. You could spend the time moving the e to the bottom, but I wouldn't mind if you left it like this. Technically plus c. Okay.
It's just to multiply by.
So you know what the derivative of e to the x is, right? What's the derivative of e to x? E to the x. Do you know what the derivative of e to the 2x is? Scarlett? No, the derivative. Remember, this would be technically a chain rule. So you would do the first thing, which is the derivative of the main thing, which is e to the 2x, times the derivative of the inside, which is times 2. That would be derivative. So because it's an antiderivative, there was a 2 that's missing here. So what I had to do is, if I wanted to go backwards and started with e to the 2x, that must have been there was a mystery 2 here, which means I would have to divide by 2 here. So the best way to, or the quick way to think about it is you divide by its derivative versus multiply by its derivative.
Okay, so how did you get to 4?
Then you divide negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8.
Okay, can you write that out?
No. You know what negative 2 times 4 is.
Wait, no, I need to like see it, like I'm confused.
Yeah, I just said it's negative 2 times 4. You cannot be confused about that.
But
Watch the video.
oh, you posted the video?
This is the video.
Wow, sorry.
It's okay. All right, let's go to trapezoid rule.
Are we doing that?
The last thing we did is trapezoid rule. Yeah. This is the answer though already. So again, if you move the e's to the bottom, that's okay. All right. So this one, trapezoid rule. Now trapezoid rule, I'm going to say I need some amount of equidistant trapezoids. In this case, if I say 5 equidistant trapezoids. So in this situation, kind of like the rectangles, you want the points from the beginning to the end. I need it in 5 spaces. So it's from 0 to 5. So it should be obvious as 0, 1, 2, 3, 4, and 5. So what I'm going to do with these numbers is plug in the number into my equation. So for example, I will take 0 and plug it into 3x squared plus 7, which is 7. Then I'll plug in this. 1, 3, 1 squared plus 7. 10. 2, 3 squared plus 7. Yeah. But let's say if you want to do that instead of quickly, you could pull out your calculator. And then you could go to y equals, plug in your equation, which is 3x squared plus 7. You get a curve, that's cool. But what you really care about is the table. So from the table, you could just get all your numbers really quickly instead of typing them in every time. So 19, 34, 55, 82. Now for the trapezoid rule, you'll take the distance of the number. So the distance of the base is this divided by how many rectangles you have. So 5 divided by 5 is 1. You're going to take out a 2. This 2 will always be here, no matter what the number is. If it was 100, it will still be divided by 2. Times, the first number is only counted once. This is base at 0. So that's 7.
Plus 20.
Now the second base is counted twice. So all the middle ones have been double counted because I'm thinking of the left side of the first one and the right side of the other one. So in this case, it's 2 times 10, or 20, plus 2 times base at the second part, plus 2 times base at the third part, 60, wait, what? 68.
What are you saying?
2 times 54, no?
100.
34, 34.
Oh.
Do you both think it was a 5?
Yeah.
My fault.
You guys still arguing?
Why would it have been 54?
Next one. Base 2 of them at base 4, at the fourth spot. 55 times 2, 110. Plus this one, the last step only gets counted once because it's the end part. There's no like second trapezoid. So this case is just base at 5. In this case, 82. From here, you just take your calculator and type it in. 7 plus 20 plus 38 plus 68 plus 110 plus 82. You get that number. Don't forget, you have a half in front of here. So I could just divide it by 2 or times by 0.5.
What is finding the table?
It got me these numbers really quickly. You could still just take 0, plug it in, 1, plug it in, 2, plug it in, 3, plug it in.
Hi, Mr. Towell.
Hey, hey,
How
good
are
to see you.
you?
Good. I'm making a video right now, so I need some time. So, thank you.
I'm leaving, but it's nice to see
You
you.
didn't
Nice to
use
see you.
those numbers. If I came back and you told me
I
you
use
were
these
making a
numbers.
video and we
Actually,
didn't
I have
even
a
see
hard
it,
I'm
then
hard
I
brain.
So this one, like 19, I just did
Like,
19 times 2,
That's so
which is
cool.
38.
So you're saying you'd be bringing like gun aid to school?
I just multiplied by 2 before I plugged it in.
I just leave the building.
Yeah, because you go to school, it's not allowed. So you're outside and you're plugged it into the.
Yeah.
Yes.
Why multiply by 2 and
So how the trapezoids are drawn, you have this trapezoid, right? And then you have this trapezoid. So what occurs is what happens is this gets double counted because it's the right side of your first trapezoid, the black one, and it's the left side of your second trapezoid. So what happens is all the middle ones get twice counted, while the end ones only get counted once. So that's why there's a 2 in all these, but none on this, on the last parts.
Oh, it's just the 2 on the.
2 times whatever you found.
But we don't need to do the middle one, right?
It's just trapezoid rule, which is his own rule, basically.
If you end up
It's your new rectangle
if you
rule.
end up multiplying the whole thing by a half, what if you don't multiply that first? That works. But that
You would then have to,
half of 7 and half 82. So like,
you would need half of this,
yeah.
and then this would be all normal and half of that. You technically could do it like that, but. I mean, you're dealing with fractions within your addition. I'd rather not. I'd rather deal with them.
Multiplying 7 times 0 isn't that.
It's not 7 times 0. When I say b of 0, it's the same thing as saying f of 0. AKA, I'm taking 0 and plugging it into my x. Not b times 0. 7 is the result, is what I get when I plug in 0. 0 plus 7 is 7.
So then, what about 20 for 2?
This is 19.
Yeah, but you got 20.
Where are you getting 20 from?
Oh, he multiplied.
This is for the first one. This is b1 at 1. If I plug in 1 here, it'd be 3 times 1, 3, plus 7, which is 10. 2 times 10,
And
20.
all trapezoids are the same.
What do you mean by that? They're literally all different.
No, but like each problem.
They follow the same pattern, yeah. There's no left, right, middle thing. You do the same steps every time. All right. Now, there's packets up here of practice. One thing I am missing is like ones with numbers. I only have ones. Like it has like the, yeah, like these, the red in here. So that's my fault. I'll print out more for that. I'll post that in Google Classroom. I'm also going to post a playlist of videos of a guy doing them already, or I don't know, Organic Tutor or whatever. He does like a bunch of examples of each section. This is just a baseline thing. Okay? This is like a overall. But if you want to deeper go into, you would listen to that, okay?
I still have my same question that you laughed at before, by the way.
What did I laugh to you? Because 2 times 4 is...
confused.